Hey guys, welcome back to chemistry class, our organic chemistry class. Now today, we are going to be looking at homologous series. What's a homologous series? A homologous series is a family of organic compounds which follow a regular structural pattern and in which each successive members differ by a CH2 group or with an atomic mass of 14. When we talk about homologous series, we actually liken this to a family name. When we have a family name, let's for instance, we have a family name like Latif. This family name is what we refer to as homologous series. Under this family, Latif, we have some children of Latif. Let's say we have Ismail, Lukman, Abiodun. Now, each of these children is referred to as a homologue. Homologue. So in this case, homologous series refers to a family, while the members of that family, each of them is referred to as an homologue. So in homologous series organic compound, the first homologous series is what we normally talk about alkane. Alkane has a general molecular formula of CnH2n plus 2. So under this alkane, we now have the members of alkane starting from methane with CH4, ethane with molecular formula of C2H6. So methane is a homologue of alkane. Ethane is another word homologue of what? Alkane. This is referred to as an homologous series. Now, what are the characteristics common to homologous series? The first characteristic is general molecular formula. Each homologous series have the same general molecular formula. The first one, we have alkane. Alkane has general molecular formula of CnH2n plus 2. Then alkane has general molecular formula of CnH2n. So each member of this homologous series will always follow their general molecular formula. When talking about alkane, the first member is methane, followed by ethane, propane. Whenever we want to form each of the member, we are going to follow this general molecular formula. Likewise, alkane with the general molecular formula of CnH2n. Second one is the physical properties. The physical properties of each member in a homologous series changes as the number of carbon atoms increases down the group. The higher the number of carbon atoms, the larger the organic compounds. Like alkane, the first four carbons, they are gases, while 5 to 17 carbons, they are volatile liquid. Then the upper carbon from 18 upwards, they are solid like wax. We all know candle wax. Now, as you move down the group, and when the carbon atom increases, their density also increases. Likewise, their melting point increases as well. But something will happen. What is that? Their solubility decreases. Because the larger the number of carbon, the lower the solubility of that particular organic compound. Third one is difference in successive members. Each member differ from each other by a CH2 group or with atomic mass of 14. Let's take alkane as an example. For alkane, with general molecular formula of CnH2n plus 2, The first member of alkane, when the N equals to 1, so we have C1 H2 times 1 plus 2. That is CH. 2 times 1 is 2 plus 2, CH4. While the second member, when our N equals to 2, we have C2 H2 times 2 plus 2. Here we have C2 H. 2 times 2 is 4 plus 2. We have 6. The third one will form C3H8. Now, let's look at this one. 2 minus 1. So we have 1, that is C. Then H. 6 minus 4, we have 2. Likewise, this. 3 minus 2, we have 1, C. H. 8 minus 6, we have 2. So each of these members differ by a CH2 group or atomic mass of 14. The atomic mass of carbon here is 12 plus atomic mass of hydrogen is 1 multiplied by 2. So we have 12 plus 2, which gives what? 14. So each of them differ with atomic mass of 14 or by a CH2 group. The fourth one is the same chemical properties. Each of these members of a homologous series have the same chemical properties. All alkanes always burn in air to give carbon dioxide and water, while the last property is the general methods of preparation. All homologous series, all the members of homologous series are prepared by the same general method. The only difference is the number of carbon atoms keep increasing whenever we want to produce the higher organic compound. If you find value in this class, kindly subscribe and click the notification bell. For my usual members on this channel, I say thank you for believing in me. I see you in my next video where we talk about the alkyl and the functional group. Thank you.